2.3 Venn diagrams and set operations. You've seen Venn diagrams before. You use them to compare and contrast things in English class. Well, to burst your bubble, guess where English class got their Venn diagram? They got it from math class. So Venn diagrams are actually math. So you see how math is literally everywhere, even in your English classes, y'all. So Venn diagrams and set operations. A Venn diagram is a useful technique for illustrating set relationships. It's named for John Venn. Venn invented and used them to illustrate ideas in his text on symbolic logic. A rectangle usually represents the universal set U. The items inside the rectangle may be divided into subsets of U and are represented by circles. The circle labeled A represents set A. So disjoint sets. Two sets which have no elements in common are said to be disjoint. The intersection of disjoint sets is the empty set. There are no elements in common since there are no overlapping areas between the two circles. So that's what it looks like to be a disjoint sets. Proper subsets. You just learned what a proper subset was in 2.2. So if set A is a proper subset of set B, circle A is completely inside circle B. Equal sets. If set A contains exactly the same elements as set B, both sets are drawn as one circle. Overlapping sets. That's the most common that we see that you use in English class. So overlapping sets are two sets, A and B, with some elements in common. This is the most general form of a Venn diagram. So overlapping is what do they have in common? All right, here's a new word for us though. All right, here's a new word for us. Complement of a set. The complement of a set, symbolized A with the little apostrophe thing, is the set of all elements in the universal set that are not in set A. Now, that's going to make zero sense until we actually practice with it in example 1, but that is a visual representation. The shaded region is the complement of A. So if I say the complement of something, you're finding what's not that. Let's find that. Let's find a set and its complement. So we're given the universal set is A, B, C, D, E, F, G, and A is A, C, E. Determine the complement of A and illustrate the relationship among sets U, A, complement of A, and a Venn diagram. So U is the universal set, meaning in this classroom, if I asked you all questions like what's your favorite color, that's all I can put in the Venn diagram are your favorite colors. The classroom is the universal set, and then I can break it down into, okay, 10 people liked blue, 15 people liked this, 2 people liked this. Then I can break it down. So the first thing we do is actually draw a box. That's probably the biggest difference between English and math class is we start off with the box and it's our universal set. All right, we only have one set, and that's set A. So only one circle, and we label it set A. Now in set A, we have A, C, and E. Now, since we put those on the page, those are used. Since those are used, we take them out of the universal set. Now, what's left over? That's what goes inside the box. So what's left over goes inside the box. So that's B, D, F, and G. So what's left over that's not in A, that's actually the complement. So the complement of A is all the elements in U that are not in A. So our complement we actually already have listed. It's whatever's left over in the box. So our complement is B, D, F, G. But doesn't that make sense of whatever is not in A? B, D, F, G are not in A. So that's the complement of A. Do not worry, we practice with complements for the rest of chapter 2. That's just our first time seeing them. All right, intersection. The intersection of sets A and B, symbolized A upside down UB, is the set containing all the elements that are in common in both sets. So this is an overlapping part. That's where they meet. So intersection is what they have in common. So it's what the sets have in common. That's what intersection means. Let's practice with that in example 2. So we have our universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is 1, 2, 3, 8. B is 1, 3, 6, 7, 8. And C is empty. So the first thing we do is we start off with the box. So we start off with a box and we name it the universal set. Now we have 3 sets. We have set A. We have set B. And we have set C. All right, now we have to fill out our Venn diagram. We're not even talking about A, B, C, D yet. We're just going to fill out our Venn diagram. So you always start in the center, then work your way out of it. So in the center is what everything that A, B, and C have in common. So I'm talking about this one right here, this portion right there. In that portion is where A, B, and C all meet. Now let's see if A, B, C have anything in common, all of them. Looking at A, B, and C, all of those together, all 3 of them have nothing in common. So we don't put anything there. We can't put anything there because they don't have anything in common. Now we move to the outer banks. So if we start in the center, we start to move out just a little bit. And I'm talking about these regions right here, these 3 regions. So those 3 regions are what we're talking about next. Let's talk about this region between A and B right here. Sorry, A and C. So what that means is we're looking to see if A and C have anything in common. So looking at A, it's 1, 2, 3, 8. C is nothing. Since they don't have anything in common, nothing's going to go there. Now let's look at this part right here. That's where B and C meet. So if we look at B and C, B is 1, 3, 6, 7, 8. C is nothing. Since they don't have anything in common, nothing goes there. Now let's look at this region right here. That's A and B. Let's look at A and B. So A is 1, 2, 3, 6, 8. B is 1, 3, 6, 7, 8. They have things in common. So finally, we get to list something between A and B. So A have 1, 3, and 8 in common. So we put it there. 1, 3, 8. So that's what they have in common. Since we put it on the page, we take it out of the universal set. All right, we did all of the middle ones. Now we're out to A, B, and C. So whatever's left over, that's what you put in each of the sets. So in A, we have 2 left over. So 2 goes here. Since we put 2 on the page, we get rid of it on the universal set. All right, looking at B, and B, we have 6 and 7 left over. So 6 and 7. Since we put it on the page, we get rid of it in the universal set. C is empty. Since it's empty, nothing's going in C. Do you notice in the C set, there's emptiness? The entire green bubble is empty. Now, what's left over in the universal set? That goes inside the box. So what's left over is 4, 5, 9, and 10. All right, now that we have our Venn diagram filled out, let's go ahead and answer A, B, C, and D. So A upside down UB, that's actually saying A intersection B. So it's where A and B meet, what answers are there. So the intersection of A and B, those numbers are 1, 3, and 8. So where A and B meet is 1, 3, and 8. That's what they have in common. Do you notice when we crossed out the numbers in A and B or underlined them, the red, that's 1, 3, 8. That's what they have in common. All right, let's do B. So B is asking for A intersection C. So A intersection C, that's right here. That's A intersection C. There's nothing there. Since there's nothing there, it's nothing. There is no intersection. So how we say nothing in sets is using an empty set. There's nothing there, so it's empty. All right, C. It wants complement of A intersection B. So what this is actually asking, what it's actually asking is not in A intersection B. So first, we need to figure out, well, what the heck is not in A? Now we need to list the numbers, every number that's not in the pink circle. So every number that's not in the pink circle, you're going to list it. So all of those numbers are 6, 7. It does not need to be in order. And then 4, 5, 9, and 10. Those are every number that are not in the pink circle. So that is our complement of A. Now, if you're like, oh, I need that to be in order, it's okay. Me too. I'm an order person. So you do not have to write it in order. Sets do not need to be in order, but I'm an order type person. So I'm going to write this in order. So if I write this in order, it would be 4, 5, 6, 7, 9, 10. That just makes me feel better. They're the same thing. They're identical. It just makes me feel better. So now that we know what not A is, we need to intersect it with B. So B, remember, B is the set 1, 3, 6, 7, 8. So what we're looking for is what do these two sets have in common? The blue and the gold, what do they have in common? So that's actually going to give us our complement of A intersection B. So what they have in common are 1, so what they have in common are 6 and 7, nothing more. All right, last but not least, D. So D, we have to find A intersection B and then the complement of that. Of course, I'm going to break it down. So what the complement of the intersection of A and B is asking is what is left over in U that is not in the intersection of A and B. So we actually already have this right here. The intersection of A and B is 1, 3, 8. So 138, that's what is in there. Now we need to figure out what's left over in the universal set. So just because the universal set's all marked up, I'm going to rewrite the universal set. All right, there's our universal set. So let's mark what we have. 1, 3, and 8. Now, what's left over? That's our answer. So what's left over? That's going to give us the complement of the intersection of between A and B. So what's left over? We have 2, 4, 5, 6, 7, 9, and 10. So you see how sometimes you're using the Venn diagram, sometimes you're not. Now, it is super helpful to have a Venn diagram, especially when we talk about applications. All right, union. The union of sets A and B symbolized A, U, B. Now that's easy to remember. U, union. It matches. Is the set containing all elements that are members of set A or of set B or of both sets. So union just means mush it all together. That's literally what I like to say. Union of sets, you're going to combine. So union, you combine sets. All right. So we have our universal set 1 through 10. A is 1, 2, 4, 6. B is 1, 3, 6, 7, 9. And C is empty. Now it's similar to the previous example, but this time we're talking about union of sets, and the numbers are different between each set. Doesn't change how we set it up, though. You like that joke? Thank you. All right, we draw a box, and we do our universal box. All right, we have 3 sets. We have set A. We have set B. I'm so bad at drawing sets. And we have set C. All right, as always, we start from the middle, then work our way out, always. That's how you do Venn diagrams. Start with what they have in common, then work your way out. So we're going to start at this part right here. That part right there is where A, B, and C converge. It's where A, B, and C meet. If I look at everything between A, B, and C, they all don't have anything in common. All of those have to have something in common. C is empty. Since C is empty, nothing can go inside C at all. Since C is an empty set, nothing can go inside C. This orange circle right here, nothing can go inside of it. Now, since that's the case, nothing can go here or here or here. Nothing can go inside those places. So there's nothing in common between A and C, there's nothing in common between B and C, and all 3 of them have nothing in common. Since I know that, I can just move straight to A and B. So looking between A and B, that's this region right here. We're going to figure out what they have in common. So A and B have 1 and 6. That's it, 1 and 6. So 1 and 6. Since we put it on the page, we cancel it out of the universal set. All right, now we write what's left over because see, there's nothing inside the orange circle. So nothing can go inside there at all. Since that's the case, we move on to A and B. So what's left over in A? We have 2 and 4. Since we put those on the page, we get rid of them in the universal set. And for B, what's left over is 3, 7, and 9. Since we put those on the page, get rid of them on the universal set. Now, what's left over goes inside the box. So we have 5, 8, and 10 left over. Now that we have our box filled out, let's go ahead and start answering some questions. So we have to find A union B. So we want to list every number that's inside the A and B circle. So you're going to list every element inside set A and set B. Those are the circles. So everything inside those two circles. Every number inside those two circles. Now it does not need to be in order. So everything inside pink is 2, 4. We also have 1 and 6. And then everything inside B is 3, 7, 9. Now, it does not need to be in order, but gosh, for me, I like things to be in order. So if we put these in order, we have 1, 2, 3, 4, 6, 7, 9. That's every number inside the yellow and pink circle. That's what union means. We combine. Alrighty, B. B is A union C. So we're not looking for what they have in common. We're combining everything in circle A and circle C. So we're gonna combine every element, every number inside circle A and circle C. Set A, set C, the pink and the orange. So everything inside the pink and the orange is 1, 2, 4, 6. I put it in order. So everything in A and C. C has nothing in it. That's okay, but A has 1, 2, 4, 6 in it. We're not finding out what they have in common. All we're doing is just combining the two sets. That's all we're doing. All right, part C. So part C, we have a complement. So we're doing the complement of A union B. So first, let's find the complement of A. So we're trying to find now the complement of A. That means that's every number, every element that's not in the pink circle, circles A, set A. So every number that's not in that set, I'm not going to write it in order, but I'll rewrite it, don't you worry. We have 3, 7, 9, 5, 8, 10. Those are every number that are not in the circle of A. So I'm just going to rewrite it for my sake. You do not have to rewrite it. That's just a me thing. So now that we have not A, let's go ahead and figure out the union of B. So B, just as a reminder, set B. Set B consists of 1, 3, 6, 7, 9. So now we need to combine these two. We combine them because it's union. Now, you never write the same number twice. Mathematicians do not like to do that because it's redundancy. So if you have a matching number, just write it once. So everything that these two, if we put them together, we'll have our complement A union with B. And when we do that, we have 1, 3, 5, 6, 7, 8, 9, 10. Do you notice that that's just everything that's not in A? A is 2, 4, 1, 6. The meaning of and or. The word and is generally interpreted to mean intersection. So A intersection B is the same thing as X, such that X is an element of A and X is an element of B. The word or is generally interpreted to mean union. So what I want you to get out of this is and means intersection and or means union. So if you see those words and you're talking about set, you're talking about union and intersection. The relationship between N, union B, N of A, N of B, and N A intersection B. To find the number of elements in the union of two sets A and B, we add the number of elements in set A and the number of elements, then subtract the number of elements common to both. We're gonna practice with that for example 4. So it's just to show you how can we find certain answers without using Venn diagrams. Now I'll tell you now though, Venn diagrams are way useful. So how many visitors speak Spanish or French? The results of a survey of visitors at the Grand Canyon showed that 25 speak Spanish, 14 speak French, and 4 speak both Spanish and French. How many speak Spanish or French? So we're going to actually answer this without using a Venn diagram. And then in 2.4, 2.5, we just use Venn diagrams. You're going to see using Venn diagrams is sometimes just easier than using formulas because we like pictures. That's how we first learn to read, is we learn to read using pictures.
So I want to know who just speaks Spanish and who just speaks French. So we're going to technically use this formula, but I'm going to show you that we really don't need to use it, okay? So to find the or, remember or is the union. That's what or means. So we need to know the number of each. So A, we can say A is Spanish. So how many speak Spanish? 25. We can say B is French, and 14 speak French. And then this part right here is both. So how many speak both? Well, they said 4 speak both. So we just put them in order and we subtract. So number of A, which is 25, plus number of B, which is 14, minus what they have in common, so 4, because both speak 4, and we get I don't know why I said 35. I was going to put 19, my bad. It's 35. I was looking at all the wrong numbers. So it's the number of the whatever you designate A to be, which is 25, and then it's adding to the number of whatever you designate B to be, which is 14, and then we need to subtract that from how many speak both, which is 35. All right, difference of two sets. The difference of two sets, we'll talk way more about applications of sets in the next coming chapters, or sections. The difference of two sets A and B, symbolized capital A minus capital B, is the set of elements that belong to set A but not to set B. So region 1 represents the difference of the two sets. Using set builder notation, the difference between two sets, A and B, is indicated by the set of A minus set B equals X, such that X is an element of A and X is not an element of B. So let's do that. We're not going to draw a Venn diagram here because we're subtracting sets. So part A. Part A wants us to subtract sets A and B. So what that is saying what this is asking is the set of elements that are in set A but not in set B. So what they don't have in common. So A and B, they have B in common, they have D in common, and they have H in common. So you see what's left over? E, F, G. That's the set. E, F, G. Part B wants us to do A minus C. So what that is asking it's the set that are in A but not in C. So in A and C, what they have in common is B, E, and G. So everything else, everything else is what is left over. So A, E, and, why did I say A? B, E, and I crossed out the wrong one. My bad. Let's start over. I was canceling out the wrong ones. All right, so what they have in common is B, E, and G. What's left over is D, F, and H. Part C. So what's the complement of A minus set B? So first, we need to find the complement of A. So what's in the universal set that's not in A? So B they have in common, D they have in common, E they have in common, F, G, and H. So everything else is not in A. So A, C, I, J, and K. All right. Now we want to take that away from B. So I'm going to rewrite set B here. So what they have in common is A, J, and that's it. Okay, sorry, I wrote down my B wrong. And I realized that. I'm not going to edit these videos because that just takes forever. It takes about start to finish 5 to 8 hours if I'm editing and stuff like that. And since this is just special circumstances, I'm not editing these. So let me rewrite B. Maybe you caught it, maybe you didn't. That's fine. Took me a minute. There we go. That's B. Now let's cancel out what they have in common. A and and J. Oh nope, that's it. Did I miss something again? I. There we go. There we go. My bad. We'll get there. We always do. So, the complement of A minus B equals what's left over, C, J, and K. Only what's left over in A because that's the first letter. My bad. My Bixby went off. It's basically Siri for Samsung. So we have C, J, and K. Holy cow. We got there. We got there. That's all that matters. All right. Going on to part D. Did I have a part D in this? I did. Okay, just making sure. Alrighty, part D. Alright, so part D, we want A minus, so set A minus the complement of set C. So what it's asking is the set of elements that are in set A but not in set C. So first things first, we always need to figure out like what that complement is. So if they're talking about complements, let's figure it out. So the complement of C is whatever's in C in the universal set, cancel those out, and what's left over. So in C in the universal set, we have B, E, and G. So everything else is the complement. So everything else left in the universal set is A, C, D, F, H, I, J, and K. Alright, so now we need to take A and subtract it to our C. So let me rewrite what A is. Alright, so that's A. Now let's cancel some stuff out. So they have D in common, F, and H. So everything that's left in A. Why what's left in A? Because that's the first letter. So everything left in A is B, E, and G. Alrighty. Cartesian product. So the Cartesian product of set A and B, symbolized A times B, is read A cross B. See how I got you there? Because we would have read that A times B, but it's actually called A cross B. And it's the set of all possible ordered pairs in the form AB, where A is an element of A and B is an element of B. So A is an element of set A and B is an element of set B. Ordered pairs in Cartesian product. So select the first element of set A and form an ordered pair with each element of set B. Then select the second element of set A and form an ordered pair with each element of set B. Continue in this manner until you have used each element in set A. So I'll show you what that means. The Cartesian product of two sets. So given set A is orange, banana, apple, and set B is 1, 2. So let's do part A. Part A is A cross B. So it is A times B. So it's a set. So you pair them each together. So what that means is we have orange with 1. And then orange with 2. And that's it for the oranges and for A and B. Now we move on to banana 1. And banana 2. So that's all we can pair from A to B. Now we do apple 1. And apple 2. And that's A cross B. So we're just putting each part of A with B. So orange with 1, orange with 2, banana with 1, banana with 2, apple with 1, apple with 2. Now let's do B cross A. So we're looking from B then to A. So we have 1 orange, 1 banana, and 1 apple. Not bad. And then we have, so we did 1 orange, 1 banana, 1 apple. Now we can do 2 orange, 2 banana, 2 apple. So 2 orange, 2 banana, and 2 apple. Alrighty, part C. Part C is a little long. Alright, so A cross A. That means we're putting A together, like in itself. So we have to do orange, orange, orange banana, orange apple, and let me rewrite A twice. That'll help us out. Alright. So we're doing each to each. So orange, orange, orange banana, orange apple, banana, orange, banana, 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 apple, apple, orange, apple, banana, apple, apple. So orange, orange, orange banana. I'm going to do OB. And then orange apple. So I'll do OA. I won't be lazy. I'll write it out. And then orange apple. Now we do banana orange. Banana, banana. That's so fun to say. And then banana, apple. Then we do apple, orange. Apple, banana. And then apple, apple. And there's our set for A times A. Or A cross A. But you know what we're talking about. Alrighty, part D. B cross B. So I'm going to rewrite B twice. Where's it go? 1, 1. 1, 2. 2, 1. and tutu. Another fun thing to say.